Right, good morning everyone. Today we are once again looking at acids and bases in our discussion. And today I want to look at something that a lot of you get wrong. And that is when they tell you that something is neutralized, right? You can often assume that the pH is 7, and that is not true. Neutralized does not mean the pH is 7. So to understand that, we are going to look at what is the different words. Now, the first word there is neutral. If something is neutral, yes, then the pH is equal to 7, right? Neutral means it's not acidic, which would have been pH smaller than 7, or basic, which would have been a pH higher than 7. It is actually neutral, so the pH is actually 7, right? Then we have a word called neutralization, and that is when you've got an acid, right? And an acid can be very corrosive and you want to neutralize that, right? It means you react it with a base. So whenever you have a neutralization reaction, it's just a reaction of the acid and the base. And you will remember that is always going to produce salt and water. Right, salt and water. Right. So whenever you've got neutralization, it will give you acid and base, salt and water. So for instance, say you had HCl and that reacted with NaOH, that would have given you NaCl and H2O. Right, so this is a neutralization reaction, a reaction of an acid and a base. Right, but when you have neutralization, there can be two outcomes. When you add acid to base, you can end up with a neutralized solution, or you can end up with something that is not neutralized, right? Now, neutralized doesn't mean pH 7. What you have to read when you read neutralized is you have to know that they are in the right ratio of acid to base. They are just in the right ratio of acid to base. So if you take for instance, if you add hydrochloric acid and sodium hydroxide, they are going to have a neutralization reaction, but only when you've added exactly the right amounts for one of those to have one of those to react with. When they're in the right ratio, then we're going to say they are neutralized. Right, so neutralized immediately going to tell you, they are in the right ratio. Right, another way that they can tell you that they're in the right ratio is they can tell you when it is a titration, right? They will tell you you are at the end point. That is another way to tell you that they're in the right ratio, or they sometimes call that the equivalence point. So all of those in a question will tell you only that they are now in the right ratio. And if they are in the right ratio, according to the equation, it means you can do ordinary mole calculations. You can work out the moles of that, and then they say 1 to 1 because they are in the right ratio. And also, if it's a titration, you can use what we call our titration equation. Right, that one where we said Na over Nb equals CaVa over CbVb. So that is only true when it is neutralized, because then they are in the right ratio acid to base. Right. But neutralized does not mean pH 7. It can be a pH bigger than 7, or it can be a pH equal to 7, or it can be a pH that is smaller than 7. Now, to understand that, we are going to look at a titration. Now, let's say we've got a titration where you've got the analyte down there, the acid, and you adding the base. Now, what I want to do is I want to add the base dropwise, and then I want to draw a graph. Now, on this graph, I want to draw the pH, right, with 7 up there, and then 0 down here, and 14 up there, which is very basic, right? And then on this axis, I'm going to draw the volume of the titrant, of the base that I've added in cube decimeters or whatever. Right. Now, let's say we start out, and for the first experiment, for an acid and for a base, I'm going to use HCl, and for my base, I'm going to use NaOH. Now, what do I know about HCl? HCl is a strong acid, right? What do I know about NaOH? That is a strong base. Right, so when I start out with only the acid down there. And it's a strong acid, so I will have a very low pH. So it will not be close to 7, it will be quite a way down, right? So there I've got my strong acid. And now I keep adding the base. So what's happening to the pH is the pH is going to increase. And I go past the end point and I still keep adding NOA. So at the end, I almost have a pure NaOH, right? So little HCl that I can actually ignore them. So if I end up with NaOH, what do I know? Strong base, so that will have a very high pH. Right. So I started with a strong acid and I ended up with a strong base. And if I have them in the right ratio, where they are in the right ratio of 1 to 1, they will be more or less halfway, and that will tell me pH 7, right? So if I've got a strong acid and a strong base, that means I will end up with a neutral solution. So the pH will be more or less 7. But let's take another example. Let's say I'm taking HCl, which is a strong acid, right? But now I'm going to use an ammonia solution, actually ammonium hydroxide. And what do we know about ammonia? Ammonia is weak. So once again, I'm starting out with a strong acid, which has got a very low pH, but I will end up not with my strong base with a very high pH, I will end up with a weak base where the pH is not as high. And then if I've gone halfway, if I've added one to the other, now you will see that the halfway point will be lower. So then I end up with a pH that is lower than 7, which is acidic. So if the acid is strong and the base is weak, it ends up being more to the acidic side, and then I will end up with an acidic solution. Right, and that also helps me to determine which indicator to use. Right, but we're not talking about that now. We're just talking about the pH. So let's take the final one, and now we are going to use CH3COOH, acetic acid or ethanoic acid. And what do we know? This is a weak acid, right? And we're going to react that with NaOH, which is a strong base. So now I've got a weak acid. What does that tell you? The pH that you start off with is not as low, right? I start with a weak acid, closer to 7, right? Not as low. But I end up with the very high, strong base. So I end up right there. So if you've added equal amounts of each, then you're going to be ending up with a pH that is higher than 7, right? A basic pH, right? So even though you added 1 to 1, even though they're in the ratio 1 to 1 at the end point, it does not mean that that end point is 7. It can be neutral, acidic, or basic. Right. So very important. Neutralized only tell you that they're in the right ratio. It does not tell you that the pH is 7, right? It tells you they're in the right ratio. You can use a mole equation or the titration equation. Right, then moving on. How about not neutralized? Now, if I add things and I don't put them in that ratio, then it will not be neutralized. And I can think of 3 examples. First example, if they just add acid and base. Say you've got a beaker with acid and you've got a beaker with base, and they're not in the ratio 1:1. If that is added together, then obviously one of them will not react. It will be in excess. Another thing is, if I've got a titration, but in that titration we have not yet reached equilibrium end point. So let's say before you've reached end point. If you've not yet reached end point, you are not yet in the right ratio, right? Or what happens sometimes, if you have learners who are working too fast, they can go past the end point. And then also you will not have the right ratio, right? So all of these not neutralized don't have the right ratio. So immediately some of that is going to be in excess. Some of that will not be able to react because there's not enough of the other one to react with. Now guys, when we talk about this, when they ask you to work out a pH, to get a value of pH, it's different from just asking is the pH higher or 7. If you want a value, they can only on school level ask you for strong acids and strong base. You can go and check the caps, right? pH is only required for strong acids and strong bases. And if you want to understand why that is true, let's look at the reaction of HCl. What do I know about HCl? If that reacts with water, it will give you Cl- in solution and hydronium ions in solution, right? And if you look at the equation, you will see one of this will make one of that, right? One of this will make one of that. And what do I know about the HCl? The HCl is a strong acid. And what does that imply? If it's a strong acid, it will ionize completely, which tells me every single molecule that I put in will do this reaction, right? So you've got 1,000 of them that I put in, and every single one will react, and the equation tells me 1 makes 1. So I end up with 1,000. So here, if I had the concentration of the HCl, right, it would be exactly the same as the concentration of the HPO plus, because every HCl is going to react and is making 1, right? So they are equal, right? But if I look at something like CH3COOH, if that reacts with water, you will also have ionization, CH3COO-, you get an acetate ion there and the hydronium ion. Right, and once again, one of this will make one of that. But this is a weak acid, which tells me that it does not ionize completely, which tells me if I put 1,000 of them in there, only a part of them will react. They ionize incompletely. So of the 1,000, something like 995 will stay like this, and only 5 will react, right? So every one that react gives you 1 hydronium ion, but there's only 5 reacting, so this is only going to be 5, right? Now this is just numbers, right? How do I really know how much of that? I have to look at the Ka value, which is products divided by reactants, is going to give me an idea of how much H3O plus. But this we are not going to use at school level to work that out and to work out the pH. When you go to university, right, in your first year, you will use the Ka value to determine the H3O plus and then do that for Pa. At matric level, we are only going to do the pH when we have strong acids and strong bases, right? We're not going to use the one with the Ka value. So when you get to this one, they're not going to ask you for weak ones and have you working with the Ka value. They're only going to give you strong acids and strong bases when they add them together, which means that every single molecule that react, if they've reacted, it means they produced pH 7, because strong and strong gives pH 7, right? So which tells me that I can ignore everything that reacted. The things that reacted is just pH 7. What I have to look at is what did not react, what was in excess, right? And then if I get the concentration of that excess, then I can determine the pH. Right, quick recap. Neutral is pH 7 and neutralization is acid and base. But when you add acid and base, the result can be that the thing is neutralized, which tells you they're in the right ratio, right? But that does not mean pH is 7, right? It can give any pH. Only thing that it tells you is they are in the right ratio, so you can do a mole calculation or use the titration equation, right? When you add them and they're not in the right ratio, and that will either be when you just add two random solutions or before or after the endpoint, then something is in excess, right? And since they only asked this for strong acids and bases, we know the part that reacted we can ignore totally, because the ones that reacted ended up being 7. So they did not add or subtract to the pH, right? So the ones that reacted we can ignore, and we just want to know how much is in excess of which one, and that will determine the pH. Right, now we are going to look at two examples to see how this is asked. Now let's look at the 2018 supplementary paper, right? Supplementary paper 2018. When I look at this, I am going to focus now on 7.2. Right, now 7.2, let's look at that first one. The learners use a concentration of sulfuric acid solution with a sodium hydroxide solution in two different experiments. Right, two different experiments. The balanced equation for the reaction is given there, right? And they say they use 24 cube centimeters of the acid in a titration to neutralize. Okay, the moment that they use that word neutralize, what does it tell you? They are in the right ratio, right? They are in the right ratio. So when I look at H2SO4 and 2NaOH, reacting, giving a lot of other things. Now we know they're in the ratio. Now what do I know about the H2SO4? The concentration was already given up there. It was 0.15 moles per cube decimeter. And now they tell me the volume of this one is 24 cubed centimeters, right? Cubed centimeters. Right, moving on. It neutralized the NaOH. And there they give you the volume of 26 cube centimeters, and they ask you to calculate the concentration of that base. Now, since they use the word neutralize, we know it is in the ratio 1 to 2. And now you can do one or two things. The first thing is you can do an old-fashioned, working out the moles of that acid, using that to get the moles of the base, and then using that to get the concentration of the base. So you can start off by C equals N over V. We're doing that for the acid, right? So the concentration being 0.15 and the volume being 0.024. Because remember, here we have to go to cubed decimeters, right? And that will give me that moles of acid, right? Right, let's see, 0.0036, and that is moles of H2SO4, right? Next up, we can move from that moles to that moles. So I can go from H2SO4 to NaOH. I know they always react 1 mole of this with 2 moles of that. So if I've got 0.0036 moles of that, how much of that will be reacting? Double that, so 0.0072 moles of NaOH. right? And then I can say, now I've got the moles of base, I want the concentration. So C equals N over V, and I'm now working with the base, right? Moles, 0,0072. I have to divide by volume, and remember, for volume you have to convert to cubed decimeters, right? You have to convert to cubed decimeters, and then you cut your concentration as 0,28 moles per cubed decimeter, right? So an old-fashioned mole calculation, or you could have done all three of those in a single titration equation. Right, you could have said acid to base is 1 to 2, right? Concentration of the acid was given as 0,15. I'm looking for the concentration of the base. The volume of the acid. Now here, since volume is at the top and at the bottom, I can just leave it in cubed centimeters. I can have 24 cubed centimeters up there and 26 cubed centimeters down there, because they're going to cancel out, right? But in that one, you have to go to cubed decimeters. There's only one volume, so nothing to cancel out with, right? And when you do this, you end up with the concentration of the base being 0,28 moles per cubed decimeter. Right, so let's recap. In this question, that word neutralize told me they are in the ratio 1 to 2. And that immediately told me I can do an old-fashioned step 1, 2, 3, right? Or I can do the titration equation, right? Now we're looking at number 2. Now they say we're still using the sulfuric acid, right? So let's say H2SO4 reacting with 2NaOH and giving you some products. I'm not looking at them, and I still have the concentration over here as 0,15 moles per cube decimeter. Right. Now, in another experiment, they are using 30 cube centimeters of this. So now they have a volume of 30 cube centimeters of this, and they're adding that to NaOH, concentration 0,28 moles per cube decimeter, and the volume there 20 cubed centimeters. Now they ask us to calculate the pH of the final solution. Now if they were in the right ratio, strong acid, strong base, it would have been pH 7, right? So obviously that is not the case. So what I'm going to do here is I'm going to work out how many moles and how many moles of acid and base is present, right? And then I'm going to see who's in excess. So first off, let's work out how many moles of the acid and how many moles of the base. Right, so for this we're going to use C equals N over V, right? The concentration 0,15. Remember the volume we have to convert to cube decimeter, so I end up with 0,03, and the moles end up being 0,0045 moles of H2SO4. Right. Doing the same thing for the base, C equals N over V. I've got a concentration of 0.28. The moles is what I'm looking for, and I've got 0,020 because now it is cubed decimeters down there. And then I end up with 0,0056 moles of NaOH. Right, so this is what they add together. And now I want to know which one is in excess. Now I can do it one of two ways. I can say for all the H2SO4, if all the H2SO4 react, I know H2SO4 to NaOH, H2SO4 to NaOH always react in the ratio 1 to 2, right? So if all my H2SO4 react at 0,0045, how much do I need of the NH? for all the sulfuric acid to air, and that would have been 0,009 moles of NaOH. And the question is always, do I have that much? No, I have only got 0,0056 moles. So that tells me that NaOH, I don't have enough, so that is my limiting agent. Right, and immediately H2SO4 is the one in excess. So I can already tell you the pH, final pH will be less than 7 because the acid is in excess. Right, but let's do it the other way around. Let's say for all the NaOH. Now we know H2SO4 to NaOH always reacts in the ratio 1 to 2. So how much H2SO4 is actually going to be used if all that 0,0056 moles of Na is used? Now that is half, right? So that means only 0,0028 moles of H2SO4 will react. And I've got 0,0045. I've got more than enough, which tells me that the H2SO4 is going to be in excess. Right. And now the question is, how much is there in excess? Remind, everything that reacted is gone and by. I don't have to think about them. They've got pH 7. I only need to know how much is in excess. Right. Now, I started off with 0,0045, and for all the NaOH to react, I used that much. So now I will know the moles of H2SO4 that are in excess will be 0,0045 that I started with minus 0,0028 that reacted. And that gives me 0,0017 moles. Right. But to get to pH, I obviously need concentration, right? So let's get the concentration of the H2SO4. Concentration is moles per volume, right? How many moles? 0,0017. What volume? Well, I added 30 cube centimeters of that, of 20 cube centimeters of that. So all together in that container we've got, at the final point after the mixing, we've got 50 cube centimeters. So that will be 0,05, and that means I end up with 0,034 moles per cube decimeter. And now I'm actually where I was last week, right? They give me a concentration of the acid, and I have to work out the pH, right? Now from the acid, I have to go to hydronium ions. So the first thing I'm going to say is H2SO4 is a strong acid, which tells me it ionizes completely. So every single molecule will react, right? And also, what do I know about H2SO4? It's diprotic. So if you think about how much hydronium ions will be produced, one of this will make two of that. So it ionizes completely, every single molecule reacts, and when it reacts, it makes two hydronium ions. And that immediately tells me the hydronium ion concentration will now be 2 times 0,034, which is 0,068 moles per cube decimeter, and then the pH is easy, right? So pH is just negative the log of that H3O plus concentration, or negative the log of 0,068, and if you do that, you end up with 1,167, which is nearly 1,17, right? So guys, with this, you really have to remember neutralized does not mean pH 7, right? Neutral is 7, but neutralized doesn't mean you ended up at 7, right? Now, if something is, if you've got a neutralization reaction, it's just a reaction of acid and base, right? If they tell you that it is neutralized, the acid is neutralized by the base, it tells you that they are in the right ratio, right? So neutralized is all about ratio. If they tell you it's neutralized, they are telling you it's in the right ratio, right? And other ways that they can tell you it's neutralized is using the word endpoint or equivalence point, right? So that means 1 to 1 or 1 to 2, whatever the equation is. And when you have that, you know you can do ordinary mole calculations. You can work out the other one because they are in the right ratios. And you can also use the titration equation, right? But when it's neutralized, even though there's 1 to 1 or 1 to 2, it's the right ratio, it doesn't mean the pH is 7, right? If you've got strong acid and strong base, then you will have a pH 7, right? But you will end up with a pH bigger than 7 when your acid is weak and your base is strong. Then the base is winning. You are ending with a pH bigger 7, right? But when your acid is strong and your base is weak, then the acid is winning and you've got a pH smaller than 7, right? So neutralized doesn't mean pH 7. It tells you they're in the right ratio. You can do ordinary mole calculations. Right, now sometimes you end up when it's not neutralized, when they just add things, or you are not yet at the end point, or you've passed the end point. Then there are something that is in excess. They're not in the right ratio. And this, they will always only ask for strong acids and bases, right? And then we know all the acid and bases that reacted, we can ignore because they, if they're strong and strong, they end with a pH 7. We can ignore them and only say, okay, I need to know what did not react. What is lying around there that did not react? And what is in excess, that will determine my pH, right? And then you have to read your question. If you have the word neutralized or endpoint, then fine, you've got the correct ratio and it's an ordinary mole calculation or titration equation. If it's not neutralized, right, then you need to work out the excess concentration and from that get the pH. So guys, this is not the only ones that it makes difficult acid and base questions. You also sometimes have two different reactions. You have a first one and then the acid is in excess and it is used in the second reaction, titration, to determine how much is in excess. Now, next up, we are going to do mole calculations because mole calculations pop up in everything. You find mole calculations in rates of reactions, you find it in equilibrium, you even find it in organic chemistry. So mole calculations, I can never tell you how important it is. It is really very important, and that is our next topic. So next week when we do our discussion, we will look at more things like that, and then we will look at the two equations and how we handle that. Right. Now, guys, remember to send us your questions at Junior Tukkies. We want to discuss the questions that you have to help you prepare for the preparatory exam and also for the final physical science exam.